folks, over on the bench again. It's Tech Tuesday. We're going to do some outside tech here coming up probably next week, talking about gear and staying warm for the winter. But today we're back on the bench. So I did the video the other day with building out our little circuits on the board, and Josh messaged me back a question on a couple of his Arduinos. So apparently he got a pretty good haul there for Christmas. But he had some stocking stuffers that were Arduino, I believe he said it was Pro Mini, Pro Micro, Pro something. But anyways, they did not come with the headers pre-soldered on the board. This is not an Arduino. This is actually, I think this is a High Let Go. Oh man, I can't read that. I think this is an ESP8266, most likely. Well, I can look in my bin. Yeah, High Let Go ESP8266. Other than that, no specific model number. I buy these things when they're cheap. Same thing with the ATmega chips. If you search around, particularly on eBay, look for the ones that have the most sold, the best views, best ratings. You can get these chips for sometimes $1 a piece or $1.50 a piece if you order a few of them. Anyway, so they're not soldered on. Josh, I don't know if you know how to solder. But yeah, don't try and do this by hand and hold it there and try and solder it. Get a breadboard. You should have breadboards in your kit. Figure out where you're going to line up. So I am going to be in one row on both sides. So let's start it. When you go to put this in there, right, long leg goes into the breadboard. I'll start at 25, one leg in on each side. I'm not going to solder this, but I'm just going to give you the idea. I typically don't solder these until I go to use them, because it may come out that I don't need to solder it. But I'm just trying to give you the idea. Seat it down. Again, long leg is in the board, short leg is out. Try and get them as level as possible. This can be a little hokey to line up at first. So now you can see we're completely flush, almost flush, well, with our leg. So you want to be flush all the way down. And then to solder this, solder down one corner. So just make your first solder on this corner. I don't know how well this will focus down for you or not, but you'll probably be able to get the idea here better zoomed in a little bit. Solder your first corner post, right? So in this case, the transmit leg. And then come over here and catch this one on the opposite corner. Now what I want you to do when you go to solder this, again, tack it down here. Tack it down here. Just tack it on opposite corners. It doesn't matter which one. Give it a second. So we'll say we start here and here. And then we're going to start here and here. Right? So you're going to do your X pattern. And then continue that X across all the way until you get to your last one. So you're going to solder at angles. The reason I tell you that is you don't want to overheat the circuit. You don't want to overheat any of the items on, the microcircuitry on the board, or the, you follow? Always solder opposites, particularly on small boards like this, because what's happening is the board is acting as your heat sink, and you can damage the components. So by soldering opposites like that, doing your X's, smaller and smaller and smaller, you're giving components a chance to cool. If you tried to solder all the way across, you're carrying a lot of heat into the circuit. So just solder on the X joints and then give it a minute, and when you're done, you can pull it out. Of course, that didn't work, but yeah, hopefully that gets the point across. If not, shoot me another question. We're just going to break this down one more time, Bonnie style. I know I keep saying that, but so pin 7. I actually need both of those, but all right, so 1, 2. Okay, let's try this. There we go. Okay. So this is our basic function. I'll clean this up later. Now I need to figure out what went wrong in that other circuit. Because as much as I hate to say it, the guy that wrote the other circuit is me. So I'm going to have to go back through and figure out what I did wrong with that circuit. I don't think it's in the reset. Yeah, I'm not sure what happened there. All right, so I'll have to go back through that circuit. Okay, so what you saw in a lot of the fast-forwarded video there was me working through wiring this up. But I'll admit I was in a highly irritated state. And what happened is I was trying to answer Josh's question about, what all is required to make the microcontroller work on its own without the Arduino board. And it's something I've mentioned in the past. I've done it multiple times, but in the process of answering Josh's question, I was mentally working a circuit in my head for the next Arduino project I'm going to do. And I mixed it up. I added portions to the circuit. And when it wasn't firing up, I blew a capacitor. And I got irritated. And I stopped recording. I deleted the recordings. And then started over in the previous segment that you saw. Kind of fast forwarded there, of just going back to the basics and building the basic fundamentals. So just to show you, this is a new Arduino. This is not the one I was using in our last segment. This is one I have not used yet. So out of the box, you'll see as it powers up that it's running a blink sketch on pin 13, which is our board level lamp, as well as the pin right here. And you'll see the power LED. So that's a brand new Arduino out of the box. That's what it does. It runs the blank sketch. Although I have gotten some that were loaded blank, which first boot always makes you go, uh-oh. But then you hook it up to the computer and hook up to the IDE, and you can upload the blank and say, okay, it does work. It's just something happened when the chip was flashed. So yeah, what I've done here is I have taken, let me just remove this, turn off this rail so there's not too much confusion. In this build out, I've emulated our power circuit, right? Our power rail in this case. We have pin 13 extends to our lamp. I have a green LED to indicate power on the rail. And then we have our power across, both VCC and negative. We have our additional pins to go to the reference crystal for timing. We also have our two drawdowns capacitors to charge the timing to make sure that we're right. And then we have our negative rail continuation for our LED because the top rail is not on. And you can see our current limiting resistor for the LED right there. So as we plug this in and we apply the power, here's our blink sketch running on pin 13. Here's the power LED. I added another one because when I do projects like this, I like to know that I have power on my rails. So that's why I add, on a breadboard, I add the LEDs to show the rails are hot. Hot is relative terms. So yeah, that's pretty much it for this week. Next week, we'll talk about actually getting a program onto here to modifying that program as far as the mechanical and electrical connections required. Electrical, but mechanical meaning you have to do something. To program these, you will need a USB to serial FTDI adapter of some type. This is one that I picked up, I don't know, a couple years back. It's the FTDI 232 chipset. This was a cheap one. It only cost me a few dollars. And I'll tell you what, I'll never do that again. Get one from SparkFun or Adafruit or Digi. Get a name brand one. This was a generic one I bought on Amazon. And it would work for a little bit and then it would stop. And then it would work for a little bit and then it would stop. But reading comments on Amazon got me on track that one of the capacitors is in backwards as well as the LED because the LED never lit up. So I had to desolder and flip the LED around, and same thing with the capacitor. I don't know why it mattered with this capacitor, but it did. And somebody else had found that same problem. So that's what we did. There's no wiring diagram. I always forget which way this has to go. But yeah, we'll go into this in depth next week. So ground is pin 1. And VCC is pin 3. Wrong end of the connector. So I'm just going to show you how this looks when it's powered up. I don't know, whet your appetites or whatever for next week. Who knows? But yeah. So we'll pick this up next week. But this, what will happen is this essentially gets pinned down to the board like that. We're going to run our power down to our rail, and we're going to carry over transmit, receive, and RTS ready to send over to the processor and then pick up from there. So that will be next week's video. All right, guys, that's it. Any questions? Comment down below. There was a rather nasty Facebook message about somebody wanted to comment on the video on the last 2 videos and say, you know, hey, you could have done this instead. But he got rather irate because he couldn't leave a comment. The reason for that is I tagged those videos for children, and commenting is disabled. But I'll put this one out, adult edit, or in a child-friendly edit, and remove some of my frustration from the actual assembly of this one, because as I'm assembling this, I was talking about what I did wrong on the other one, and yeah, I think we're all old enough to know that you get frustrated at yourself sometimes. So, all right, guys, that's it. We'll see you later.